Good morning and welcome to the inaugural broadcast in our new webinar series. A couple housekeeping things. During the webinar, if you use your control panel on the right-hand side, you can send questions about any of the items that I'm covering today. At the end of the webinar, about 15 minutes, I will be answering those questions live, so that everyone can get their answers to their questions. So let's start by taking a look at the agenda we're going to cover today. We're going to look at how Polka in a manufacturing environment reduces manufacturing lead time. To do this, we are going to explore three fundamental concepts of Polka. Polka loops in manufacturing, how the Polka card controls movement of jobs between different work centers, and how the Polka dispatch list keeps job priorities in the correct sequence at each individual work center. In a job shop or process environment, we have a classic way. We have work centers that do different things. In this example, we have straight and cut, end rounding, forming, and press. We have a job that gets entered into the system, and it starts its progression. In a typical job shop and process environment, most of the time it takes to get the job done is the job sitting at a work center waiting for all the other jobs that got there before it to be finished. In this example here, the red is showing the amount of time that the job is stopped waiting for the jobs in front of it to be worked on. The green shows the actual setup and run time when capacity of the work center is being consumed. And this is a classic job shop and process industry environment. In the example that we're going to be working with this afternoon, we're going to look at 4 work centers: straight and cut, forming, end round, and press. These are actual work centers at a client of mine, Wi-Tech Industries in Rahway, New Jersey. Wi-Tech has a classic job shop environment. They don't start a job until a customer places an order, and they build whatever the customer orders. So the path any particular job takes through the work center, in this example, straight and cut to forming to end around to press, another job may start at end round, go to forming, and then to press and out the door. The example that we're going to be working on is straight and cut to end round to forming to press. Now, if you walk into Wi-Tech today and walk out into production, you will see above each work center signs that look almost identical to these charts that I have on this slide right here. You see, Polka is a visual system that is run by the operators on the floor. They're the ones that control the movement of material between work centers. In our example here, these work centers have been activated by this particular job. Work centers are only activated when we have a job that needs that technique, as we saw in the previous example. And jobs can take many different paths through this. To calculate these Polka loops, now Wi-Tech has 9 work centers. We look at their planning lead time. How far out into the future do they have jobs scheduled going through their production environment? Wi-Tech has a 5-week manufacturing cycle. So their window that they're looking out is 5 weeks into the future. And every time they replan, it changes the mix of polka loops that are going to be activated to make the product that's coming through at that particular time. We then know the volume of work that's going to be going through, and that leads us to the second polka concept. The polka card itself. Again, visual system. It states the department that is sending the job, in this case yellow, end round, and the department that the job is going to, in this case forming, khaki. Now, a visual system. It ties into the visual colors that were hanging over each work center. This card represents capacity at the forming work center. In our environment at YTech, this is 2.5 hours worth of capacity. So if the job has to run in 2.5 hours or less, it needs 1 polka card. If the job that's going to be done in forming takes more than 2.5 hours, it needs 2 polka cards. And the quantum of work, that's Surrey's term for how much capacity 1 card represents, does not have to be the same for every job, every work center. Now, I mentioned that this is a visual system. At YTech in Rahway, the majority of the people that work in production are Hispanic. Everyone has to be able to read and speak English. However, English for many of them is a distinct second language. So, the visual nature of it, everyone can see where the card's coming from, where it's got to go. They can see the color coded up on the overhead. If they need to, if there's any questions, they can read. Now notice each card is serialized. That's because the quantity of cards in any given polka loop, in this case end round to forming, varies depending on the planning, the jobs coming through in the planning horizon. So in order for the manager, the polka manager, to maintain the correct number of cards, they have to know each card. That's why they're serialized. Now in our example, this job started out in straight and cut. It went to end round. End round completed its portion and sent the card to forming, sent the job and the card to forming. Forming gets the job, and now they have to look at the work order to find out where it goes next. In this case, when they are done forming, it goes to press. Before forming can start working on this job, they have to have the polka card from the forming press loop, and they must overlap it with the card coming from end round to forming. This is the concept of paired overlapping cards. A visual signal. It came in from end round to forming. It's going from forming to press. You now have the 3 colors. Boom, boom, boom. This is one step closer to authorizing forming to start running this job, because now they know when they get this job done and send it to press, press has the capacity available right now before forming even starts their operation to actually work on the job as soon as it gets there. The last step is a dispatch list. Excuse me. The dispatch list keeps the priority sequence correct. Now you notice our job This is the forming dispatch list for today, Tuesday, January the 12th. Job number 58219 is authorized to begin production in forming today. Its next cell it's going to is press. Forming can work on this job. They've got everything they need. However, if this job was not there and forming had another job 3 lines down, 56971, that's also going to press, they're not allowed to start working on it today because this job, to keep it in priority sequence, should not be started until Wednesday, June 13th. Now, the question always comes up, well, what happens if there's no work for forming to do and they got this job 56971 sitting there? This is the discipline that has to be installed. You don't work on the job. It's a visual signal to the forming supervisor that they got to go find out where the job is that they need 58219. What's holding it up? Visual system. But this is real manufacturing, and we all know how it goes, that they don't want to sit there doing nothing, so they pick up 56971 and start working on it. Murphy's Law is alive and well in manufacturing. The next thing that happens is as soon as they get the job 56971 set up and started to run, 58219 will come in. And what they're going to do is they're going to run 56971. It'll get done early. 58219 will get done late. So it's a discipline thing. But with those 3 straightforward basics of the polka loops, the polka cards, and the dispatch list, look at what happens to the lead time. Same job, same 4 work centers. Now, because the job can be worked on almost as soon as it comes into the work center, the elapsed time has gone from 34 days to 3 days. 34 days to 3 days. What we've covered in this short webinar is looking at polka reducing lead times, and the lead times it's working on is that queue time, the amount of time the job sits in front of the work center before it's picked up and worked. To do this, we need to know which polka loops are going to be activated over the planning horizon. Then we need to put in the polka cards in sufficient quantities to handle the volume of work coming through over that planning horizon. And to keep everything in order, we have a daily dispatch list. So, at this point, I would be more than happy to take any of your questions.